All right, welcome back to Mr. P Helps with Calculus. This is Unit 0, Day 11, and we're going to be getting into some basics of trig, talking about the unit circle, and talking about when it's positive or negative, the three main trig functions. Starting off with a warm-up here about using Pythagorean theorem. I'm not going to do both of these, save a little bit of time. So we have 5 squared plus 12 squared equals, now let's make this C because it's the hypothesis, hypotenuse, sorry, not hypotenuse. So 5 squared is 25, and 12 squared is 144, and that equals C squared. So add these two up, you get 169, and that is a perfect square of 13. C is 13. Negative 13 wouldn't make sense in the context of this question. This is a 5, 12, 13 triangle, one of the most common triangles that you will see out there, other than 3, 4, 5, probably the second most common. All right, so here's what the unit circle looks like. I would highly suggest you be able to know how to do this. A couple of the basics, so just basics of reading this. It's not really about memorization. You do have to memorize some of these numbers. To me personally, I always remember that sine of 30 is 1/2. And I know that 60 degrees and 30 degrees are basically this exact same answers, only in reverse. Square root of 3 over 2, 1/2, and 1/2. And keep in mind, these are all cosine, comma, sine, because that's what cosine is. It's the x value of making a right triangle, right there. Whereas this one, right triangle, is going to be here. So it's going to be the exact same 30 and 60. So one side's 30 in a special triangle. If one side's 30 in a right triangle, then the other side has to be 60. It's literally the same triangle. You're just flipping it around. Now, that's the reason why the answers are the exact same thing. Now, tangent, 45 degrees is that isosceles triangle. It's both square root of 2 over 2 for both of the answers. Now, all of these answers over here just are basically all based upon what quadrant it's in. So if it's in second quadrant, you know it's going to be a negative cosine and a positive sine because it's literally left negative and up positive, or anything here is negative because of the quadrant that it's in. But this 30-degree reference angle is going to be the exact same as this 30-degree reference angle. So it's got the exact same answers. The only difference is it's negative instead of positive because of the quadrant that it is in. And I know that was a really quick way of doing it, but those are some of the important basics. Now, the other thing that you need to know is how to recognize these, how to do all of the radians. So keep in mind this is 1/6 pi. So just know that 30 degrees is 1/6 pi. And then this would be 2/6 pi, 3/6 pi, 4/6, 5/6. 6/6, which is really just one whole. Now, I'm giving it to, you can simplify some of the ones that I'm saying. 7/6, like 8/6 can be reduced down to 4/3, then 9/6, and then, 9/6, and then 10/6, and then 11/6, and then 12/6, which is really 12 divided by 6 is 2 pi. So it's 2 pi to get all the way around. So you could do the exact same thing with 45 degrees. So that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So it's really not about memorization if you understand how it works and you can just literally just count around. Okay, so trig identities, here's are the most basics that you can possibly get. SOHCAHTOA is probably what you've heard before. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, and there it is. So keep in mind, tangent is also sine over cosine because opposite and adjacent happens to be the height over the x. Tangent, opposite over x, right? Because when you have a circle, let's say the reference angle is here. So opposite to this angle would be the height, and the adjacent would be the x. So that's why it's, sine over cosine. And then we have the reciprocals, just the exact same thing flipped, so not necessarily inverses, but they're the exact same thing flipped. So we have cosecant, secant, and cotangent. All right, so now determining quadrants. So the easy way to remember it is all students take calculus. All 3 signs are positive in the first quadrant because it's positive. Only sine's positive because it's on top. Tangent's the only one positive here because it's sine divided by cosine, negative divided by negative is a positive, so that's the reason why tangent's positive here. And then cosine's the only one that's positive in the fourth quadrant. So now, doing an example of one of these, when it says sine of theta is less than 0, meaning sine of an angle is negative. So that already tells us that we're in either the third or fourth quadrant, because if sine is negative, we know it's below the center height. Cosine is positive, means it's to the right, which has to be either quadrant 1 or quadrant 4. Now, the only overlap here would be quadrant 4, so we know that this was quadrant 4, because it's the only quadrant that meets both criteria. And you would do the other ones exactly the same. Now, when you get to cosecant, just keep in mind cosecant works the same way as sine. So sine is positive in the first and second. Cosecant is also positive in the first and second because it's literally the same thing, just flipped. So a positive number over a positive number is still going to be positive when you flip them. So keep that in mind as well. Sketch a right triangle and then find all 5 of the trig functions. Now this is going to take some time. In fact, this will take a lot of time, so I'm definitely not doing both of them. So let's say this is theta right here. Sine is opposite over hypotenuse, so that's 1 here and that's 3 here. Excuse me. First thing I need to do is I need to figure out what this x is right here. So that would be something squared plus 1 squared equals 3 squared. So a squared plus 1 equals 9, and then subtract 1 from both sides, and you end up getting a squared is 8, and square root of that would be square root of 8. So I'm just going to leave it square root of 8. I know that can be simplified. I'm going to leave it just like that. So the next thing I can do is, now that I have all 3 sides, now I can write sine of that angle, cosine of that angle. Well, sine of it was given to us. So cosine of that same angle will be adjacent over hypotenuse. So that would be square root of 8 over 3. Tangent of that exact same angle will be opposite over adjacent, so that's 1 over square root of 8. Once again, I know these can be rationalized, but I'm just going to leave them the way they are. Cosecant is the reciprocal of sine, so that will just be 3 over 1. Secant is the reciprocal of cosine, so that will be 3 over square root of 8. And then we have cotangent, which is the reciprocal of tangent, and that would be square root of 8 over 1, or just square root of 8, to be honest. All right, and you would do the exact same thing for this one. Just keep in mind secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, that's hypotenuse over adjacent. Excuse me. All right, determine the exact value of these. Now, keep in mind that sine of 60 degrees is going to be square root of 3 over 2. That first answer can literally be found on the unit circle. So sine of 60 degrees. Keep in mind, remember what I said, sine of 30 degrees is 1/2, so I know it has to be the other answer. That's my way of memorizing. Cosine of 5 pi over 4. So the first thing I need to ask myself is, where on the circle is that? So this will be 1 pi over 4, that's 45 degrees, 2 pi, 3 pi, 4 pi, 5 pi. So I know I'm right here. I know I'm in the third quadrant. I basically have a 45-degree reference angle in the third quadrant. So cosine of 45-degree angle is square root of 2 over 2. And then the next thing I ask myself is cosine positive or negative? Well, it's to the left, so it's negative. Negative square root of 2 over 2. All right, 300 degrees is the same thing as a 60-degree reference angle in the fourth quadrant, because, 360 is right here, so that's 60 less than a full circle. So we know we're dealing with a 60-degree reference angle. So cosine of 60 degrees happens to be 1/2. Now, the second thing I need to ask myself is, well, is it going to be positive or negative? Well, if it's in the fourth quadrant, it's cosine, then we know it's going to be positive because it's to the right of the center. For the next one, we have 5 pi over 6. So let's see. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi, 5 pi, 6 pi. Okay, sorry. It would be a 30-degree reference angle in the second quadrant, which is a 30-degree angle. So sine of 30 is 1/2. And it's in the second quadrant, so I know it's going to be positive because it's above the center height. It's higher than. Now, negative pi over 6 is really just going the opposite direction. So that's going to be a 30-degree reference angle in the fourth quadrant. Because you're just going backwards instead of going counterclockwise, you're going clockwise. So the sine of a 30-degree angle is 1/2. Now, it's going to be negative because it's below the center height. And there's your answer. Determine the exact value. So tangent of pi over 4. Tangents, you know what, those are the exact same thing. So I'm gonna skip those because I got some more things I want to get to. Pythagorean trig identities. So these are things that can be useful when solving these identities. So when it says cosine squared plus sine squared, that equals 1. That's literally the identity right there. Sine squared plus cosine squared. And the other ones are literally just the exact same thing, just rearranged. For instance, if I move the cosine squared to the other side, it becomes 1 minus, because I have to take away from both sides, it becomes 1 minus cosine squared of theta. I know these aren't really going to work out too well. Sine squared of theta, right? Because if you take this and you move sine squared of theta to the other side by subtracting from both sides, you end up getting the exact same thing. This is just another trig identity, but you're literally doing the exact same thing. So 1 plus tangent squared. So 1 plus tangent squared is secant squared theta. And you can literally find all the other answers by just literally moving things around and switching places. Like if I move secant squared to the other side, it becomes tangent squared minus secant squared, but I have to move the 1 to the other side over here, and it becomes negative 1 is the answer. I don't want to do too many of these because I know we're going to focus on that on the next video. When I look at this, and these are trig identities, and being able to simplify them, I noticed that both of these happen to have sine of x involved. So I'm going to factor out that sine of x, and that leaves me with cosine squared of x minus 1. Now, going back to that trig identity, cosine squared of x minus 1 is literally equal to negative sine squared of x. So this is the same thing as negative cosine squared of x. So negative sine squared of x. And then when I multiply that by sine of x, I get negative sine cubed of x. And there's my answer. All right. For this question, so I can literally factor this. So using that other trig identity, this cosecant squared of x becomes cotangent squared of x plus 1. That's literally the same thing if you rearrange it from that previous one. And then minus cotangent of x minus 3. Now, the parentheses really aren't needed because there's nothing I can do inside here, so I can combine these two, and now I have cotangent squared of x minus cotangent of x minus 2. Now I can factor this. So I'm looking for two numbers that give me negative 2, but also add up to negative 1. That'd be negative 2 and 1. So this is cotangent of x minus 2, and then times cotangent of x plus 1. There you go. There's a factored form. If you use FOIL, you literally will get the exact same thing. It's factoring exactly the same way as you have done in the past with the trinomial. And you're doing, consider this A, B, and C. And just figure out what two numbers multiply to get C and add up to B. All right, I'm going to stop it right there. Thanks again for watching. Have a wonderful day, and please look forward to the next video.